Wow. You got the circumference of a triangle. Nice. Okay, here we go. Um, I'm not going to rewrite it all. I'm just going to talk about, and you can rewrite as we go. Okay, extreme values over a given interval. Here's what you want to mark right away. Circle the maximum and circle the minimum and label them as follows. Okay, some graphs have what we call maximum values and minimum values. There's two types of max and mins. One is a global maximum, meaning the largest value that the graph achieves, period. And one is what we call local, meaning it's greater than everything else immediately around it. Okay? So, in this situation, we call that a local maximum. If you go just to the left of the local maximum, is the function increasing or decreasing? Is it on its way up or on its way down? Just to the left. It's on its way up. And just to the right of the maximum, it's on its way. So that local maximum happens where it changes from increasing to decreasing. So that's a good definition. It's not a great definition. We actually learned the true definition of a local maximum, local minimum in calculus, but we're introducing the idea right now. The local minimum, if you look just to the left, it's decreasing and it changes to increasing. So that's the definition of a local minimum. You're going to look at those points over the course of this unit. They are, love it when that happens. They are extremely important to our success in doing mathematics and applying to real world situations as we move forward. And truly, these points right here, I know this sounds maybe a little bit exaggerated, but it's true. These change the shape of the world, okay? Our ability to work with these maximums and minimums allowed us to do great things in this world technologically, okay? And you'll see that as we move forward into our applications and then eventually into calculus. Some really, really cool stuff. So here's what we have. We have two types of parabolas, and we will call them vertex form and standard form. You can label those vertex form and standard form. Last year in your Algebra 2 class or whatever you took, you probably talked about standard form most of the time. We're going to deal with standard form today, but vertex form is what we're going to deal with shortly after that. And you're familiar with vertex form because this is the transformation. H units to the right and then K units up, so on and so forth. So if I had a function that was graphed in vertex form that looked like the blue, we would say that this vertex right here, that's the point of the maximum or minimum, has what we call an extreme value. The location of that vertex is just HK. It's the horizontal shift and the vertical shift. We just tested on that, right? We've been shifting functions around. The extreme value of that function so the extreme value of f of x is the y value. So is this a maximum or minimum here? It is a minimum. It has a minimum value of k, and it happens at an x value of h. The red function, if I had an equation in standard form, also has an extreme value. In this case, I chose to draw it upside down. Is that going to be a minimum or a maximum? It is a maximum. And the maximum value of f of x is wherever that vertex is. Now, here we don't have h and k, we have a, b, and c. And so in order to find that vertex, we actually use those letters. We take negative b and divide it by twice a. To get the y value, we take whatever that is and we plug it back in. F of negative b divided by 2a. So the extreme value is going to be f of negative b divided by 2a, and it happens at x equals negative b divided by 2a. I will now show you something that should create a light bulb inside your brain. Keep that in mind. Negative b divided by 2a. You see it? You recognize that? What is that? Quadratic formula. Okay? So, quadratic formula helps us find which parts of the graph. The X-intercepts. So I'm going to rewrite this. Okay, you like that? So what is that? This right here looks familiar, doesn't it? What is that? That is the x-coordinate of, thank you, x-coordinate of the vertex, right? So look, this is right here, negative b divided by 2a. How do we find the x-intercepts? We add the square root of b squared minus 4ac over 2a, and we subtract b squared minus 4ac over 2a. That's what the quadratic formula does. You see that? Nothing in mathematics is just made up, as like we don't know where it comes from. It definitely comes from a source. So flip it over. We go to this page and take out your worksheet as well. There's a back sheet to it, and I want you to tear that off, okay? Look at this sheet right here that says graphing parabolas. You want to have that out. Cool. This is not what you will use on the test. You do not get notes for the test. But what you do get is a sheet that will help you memorize the characteristics of your parabolas. So we'll spend 3 days on this. We'll spend today and then Monday and Tuesday, and then we'll move on to 2.7. Standard form of your function is ax squared plus bx plus c. The direction is up if a is positive. Did you know that? We just learned that, right? And if a is negative, it goes down. I tell you how to find the vertex. Axis of symmetry we will talk about in a second, but is simply x is equal to the x value of your vertex. The y-intercept is easy. It's just whatever c is on the end. And finally, in order to find the x-intercepts, we factor or use the quadratic formula. So have that sheet ready to go because we're going to go over all those examples as we do this one right here. 2x squared minus 8. Sketch a graph of the given parabola and state the coordinates of its vertex and its intercepts. I will start with this. What is the direction of this parabola, up or down? It goes up. Very good. The vertex, this is in standard form, so I will do negative b divided by 2a. First, I should identify a, b, and c. What is a? 2. What's b? 0. What's c? Negative 8. Notice b is not the second value. It's the value in front of x, and you have no x, so it's 0. So the vertex, I will take negative b and divide it by 2a. So it'll be negative 0 divided by 2 times 2, which is going to be 0. How do I find the y value? I plug it back in, and I get negative 8. So I'm going to plot that. A of S, axis of symmetry, is always this. X equals, what is the X value of your vertex? 0. Negative b divided by 2a, which is 0. So the axis of symmetry is a vertical line that divides your parabola exactly in half. That's x equals 0. That means if we have a point on the right, we can reflect it over the axis of symmetry to give us a point on the left. So we have direction, vertex, axis of symmetry. How about the y-intercept? What is it? -8. Have we already plotted that? Yep. Nothing special. And then we have the x-intercepts. In order to find the x-intercepts, I set y equal to 0. And then I have two choices. I can either factor or use the quadratic formula. Does this factor? Yeah, so 0 equals 2x squared minus 8. What do I factor out? 2 times x squared minus 4. Does that factor? 0 equals 2 times x minus 2 times x plus 2. What are my x-intercepts? Yep, plus or minus 2. So I can plot positive 2 and negative 2 and sketch that graph. Does this graph have a maximum or a minimum? What is the minimum value? Well, all of this is the answer. On your worksheet, you're going to be asked to find different parts of this function. And I'm giving you all of the pieces so we could just do 2 examples as opposed to 8 that involve different steps. Okay. So the next one's more difficult. Why? I'm convinced that she is not even hurt. She is not even hurt. Okay. She goes home and laughs every day and says, "Do you know what I got to get people to do?" She's already had me go on 4 errands. She's like, "Oh, I forgot to pick this up downstairs." Yeah, I bet. I bet. Is she a, what is this? Are you even hurt? All right. Anyway, B, what's the direction? Down. Vertex, I have to do negative b divided by 2a. What's negative b? 6 divided by, what's 2 times negative 1/4? 2 times negative 1/4. Negative 1/2. What's 6 divided by a negative half? Negative 12. How do I get the y value? Plug it in. Negative 12 squared is 144. And a fourth of 144 is 36. So negative 36. And then negative 6 times negative 12 is positive 72 plus 3. So negative 36 and positive 72 is positive 36 plus 3 is 39. Axis of symmetry is always x equals what value? The x value of your vertex, which is negative 12. So you can see that makes sense because if you plot negative 12, positive 39, your axis of symmetry will go right through there. What's the y-intercept? 3. So I could reflect it over somewhere over here. I'd have another one. What's the last thing I need to find? X-intercept. And you guys, if we'll probably finish this, but if we don't, please stay. I don't want to. We need to finish this example. So the X-intercept. If you want to go on a separate sheet of paper, I don't have room. I need to go somewhere else to do this problem. But to find the X-intercept, is this factor? No. So I need to use the quadratic formula. And so I'm going to take this and set it equal to 0. Negative 1 over 4 x squared minus 6x plus 3 is equal to 0. Now, at this point, you can play around with the equation because you're simply solving where is equal to 0. I don't like the fractions plugged in the quadratic formula. Do you? So multiply through by, how about negative 4? I get x squared plus 24x minus 12 is equal to 0, right? You just multiply through by negative 4. I like that better. Yes, I have some big numbers, but oh well. Let's do it. Negative b. Plus or minus square root of. Not a minus. Square root of what's b squared? 576 minus 4 times a times c. All over 2a. All right. How many negatives do I have underneath square root sign? 2. And so that's going to be a plus. So 576 plus 48. 624. Well, what's it divisible by? Okay, here's what I do when I divide this up, you guys. I just try to see how many times it's divisible by 2. Like 624 divided by 2 is 312. So once. Divide by 2 again. 156. Twice. So I could take out a 4, couldn't I? Let's try it again. 156 divided by 2. 78. And 39. So it's divisible by 2 4 times. What's 2 times 4? I'm sorry. What's 2 to the 4th power? 2 times 2 times 2 times 2. 16. Negative 24 plus or minus the square root of, we have 16 times 39, right? All over 2. So negative 24 plus or minus 4 roots of 39 over 2. What can I take out? So I have negative 12 plus or minus 2 roots of 39. Look at that. Negative 12. What is that? What's negative 12? X value of my vertex. We just go to either side plus or minus 2 roots of 39. You see where it comes up, right? This isn't magic. So you have to express this in 2 ways, folks. Number 1, you express it as negative 12 plus or minus 2 roots of 39. You have to express it in simplest radical form. But in order to plot it, you need to convert it to a decimal. So how do you make it into a decimal? Just type in your calculator negative 12 plus 2 roots of 39, and you get 0.49. And take negative 12 minus 2 roots of 39, and you get negative 24.49. So then I can plot those x-intercepts, or at least, something close. Draw my shape. I know that, hold on. I know that was quick, but that was review as well, okay? All those are pieces that you actually saw with Miss Kruger and then with Miss Nelson. So here's what I want you to do, okay? Take your worksheet, which I gave to you, the properties of parabolas. You need to mark this down, folks. Okay? Notice that 1, 2, 3, and 4, it simply says identify the vertex. You don't need to do anything else. For graph each equation, do the vertex and the x and y intercepts for 5 and 6. For 7, max and min, vertex, and x-intercepts. If you flip it over on the backside, same thing for 9 and 10. But then 11, 12, 13, 14, you don't have to make a graph and you don't have to find x-intercepts. So for those other ones, you don't have to graph it. You don't have to find the X-intercept. So those should go quicker. Work on this weekend. Don't put it off, okay? Have a good weekend. It's Friday, folks.